Okay, welcome back. So in the previous class, we were discussing about a pair of linear equations. Like there are two linear equations. Each of them will represent a straight line. And we were trying to investigate the different possibilities. Okay, so like a general linear equation will be of the form ax plus by plus c is equal to 0. And this is going to represent a straight line. If you have two linear equations, they will be of the form a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Okay, so this is what we call a pair of linear equations. And just like, if you take a linear equation, there are infinitely many points on the graph of the linear equation. Because say, for example, if you have say 2x plus 3y is equal to 5. This is a linear equation. You can see that it's a straight line. There are infinitely many points on the straight line. Okay, in other words, the common condition that is being satisfied by every point on the straight line is represented by 2x plus 3y is equal to 5. Okay, that's the idea. So when you say that 2x plus 3y is equal to 5 is the equation of a particular line, it means that 2x plus 3y is equal to 5 is the equation, a common condition that is being satisfied by every single point on that straight line. That's the idea. Or in other words, if you take 2x plus 3y is equal to 5 and take all possible points, all possible ordered pairs that will satisfy the condition 2x plus 3y equal to 5, and if you plot these points on the graph, the shape of the graph is what we have in the screen, right? So that's the idea about straight line. Now, when you have a pair of straight lines, when you have a pair of linear equation, they are going to be a pair of straight lines. And let's try to interpret this both graphically and geometrically. So in the last class, we were looking at the graphical interpretation. There are algebraic methods to solve a system of linear equations, a pair of linear equations. There are algebraic methods as well. So for the time being, we are looking at the graphical interpretation. We have just seen that these two straight lines will represent, two linear equations will represent a pair of straight lines. And there are different possibilities. Okay. And one possibility is the lines being coincident. Okay. You can say that coincident lines, they are coincident lines. Coincident lines. What do you mean by coincident lines? Both lines will be exactly the same. Both lines will be exactly the same. Okay. Say, for example, if you have 2x plus 3y is equal to 5 or 2x plus 3y minus 5 is equal to 0 is an equation. Now, suppose if I multiply the entire equation with a number, multiply the entire equation with a number, say, for example, we have 4x plus 6y minus 10 is equal to 0. We are going to get a different equation with different coefficients, etc. But don't you think these two are the exact same, right? Don't you think these two are the exact same equations, exact same conditions? Tell me that. Please tell me. Hello? My question is, don't you think these two straight lines, don't you think they will represent the same straight line? These two equations, don't you think they will represent this exact straight line? Yes. Okay. So the condition for coincident lines is very simple. Okay. The coefficients has to be proportional. 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 That's very simple. If you have coincident lines, if we have coincident lines, we have 2 by 4 is equal to 3 by 6 is equal to -5 over -10. Okay, now if I go and plot 4x plus 6y minus 10 is equal to 0, you're going to get the same straight line. See, this is the red line. This is the blue line. Now, this is the blue line. This is the red line. Blue, this is red. Okay, when you plot them together, they are indistinguishable. They are exactly the same. Exactly the same. So, just by looking at the equations without drawing the graph, how can you say that the straight lines are coincident? The condition is very simple. The coefficients has to be proportional. Please note it. Please note it. If you have a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, the condition for the lines to be coincident is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Coincident lines. Coincident lines. Coincident lines. Okay, coincident lines. Clear? Is that clear? Is that clear? Yes. Yep. Now in terms of solution, what do you think will the common solution of this pair of linear equations will be? What do you think will be the common solution? Since these two lines are completely coincident, one lies completely on the other line. Okay, every point on the lines is a solution, is a common solution, right? So we say that the system of linear equation or the pair of linear equation has infinitely many solutions. Okay, infinitely many solutions. Infinitely many solutions. You can also say that these two equations are dependent. You can also say that these two lines are dependent. So one term is infinitely many solution, other term is dependent. And by the way, the technical term, the math term for having a solution to a system of equations is what is called consistency. If I say that a system of equation is consistent, it means it has solution. So another term is consistent. Consistent. Of course, it's consistent with infinitely many solutions. 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 All right. Consistent with infinitely many solutions. Now let's quickly do one question. Quickly do one question. Question. 3x plus 2ky is equal to 2. Another equation is 2x plus 5y is equal to 4/3. Please note down the question. 2x plus 2ky is equal to 2x plus 5y is equal to 4/3. What is the value of k so that the system of equations has infinitely many solutions? Question is, what is the value of k? What is the value of k so that the system of equations will have infinitely many solutions? Can you just give it a try? What is the value of k so that the system of equations has infinitely many solutions? Can you give it a try? Please give it a try. The value of k so that the system of equations has infinitely many solutions. What should be the condition? The coefficients should be proportional. The coefficient should be proportional. Remember, we have to write both equations in the similar form. Okay. If the constant is on the RHS, it has to be on the RHS for both equations. If the constant is on the LHS, it has to be on the LHS for both equations so that you don't get confused. Okay. Now, afterwards, take the coefficients and write the proportionality. Do we have a value for k? Do we have a value for k? Are you with me? Is there a confusion? Please let me know. You have the answer. Please let me know. Please let me know. Okay. So how do we do it? The coefficients has to be proportional. So we have 3/2 is equal to 2k over 5 equal to 2/4/3. Is this clear? Is this clear? Is this clear? Give me a yes. Yes. Now we have 3/2 is equal to 2k over 5 is equal to 2 times 3/4. So this comes out as 3/2. 3/2. So we can just figure out the value of k, right? We can just get the value of k. You just equate these two, find the value of k. Equate these two and find the value of k. What do you think will be the value of k? 3/2 is equal to 2/5 times k. So k will be, when 2/5 is multiplied with k, when it goes to the other side, it becomes multiplication with 5/2. 5/2, right? So your 2/5 times k is equal to 3/2. Your k value will be 3/2 times 5/2, which is 15/4. Is that all right? 15/4. 15/4. 15/4. Please let me know if you have any confusion. Please let me know. Please, please, please. Yes, cool. Simple, right? Simple. So that is our case number one. Case number one is when you have a pair of linear equations, if the coefficients are exactly proportional, which means that they are coincident lines. Other term is dependent equations. Okay. And as far as solutions are concerned, we can say that the system has infinitely many solutions. infinitely many solutions. Infinitely many solutions. You can say that the system is consistent with infinitely many solutions. Consistent with infinitely many solutions. Now, what happens? What happens? So that is next is case number 2. What happens if you have, say, initially we had 2x plus 3y is equal to 5. Okay, or 2x plus 3y minus 5 is equal to 0. Now, you know that 6x, if I multiply with 2, we have 4x plus 6y minus 10 is equal to 0. You know that these two will be coincident because the coefficients are exactly proportional. Now, what happens if I change the constant only? If I change the constants, say instead of minus 10, if I write, say, some minus 7, what happens? What happens? What happens? So in the second equation, instead of minus 10, I'm going to write it as minus 7. See, they are parallel. Now they are parallel. Now they are parallel. Now they are parallel. Okay. Got it? Did you get this point? They are now parallel. Okay. Now they are parallel. Okay. They are now parallel. Is that clear? Is that clear? Now, if I keep the proportionality the same for the coefficients of x and y, but change the proportionality for constants, then you are going to end up with a line which is parallel to the other line. There are two lines which are parallel to each other, right? Is that clear? Is that clear? Keep the proportionality intact for the coefficients, but for the constants, you just break it, break the proportionality. Got it? Tell me, give me a yes. So you are going to end up with a line which is parallel to the original line. Now tell me, in this case, what do you think will be the solution set? What do you think will be the solution set in this case? Since these two lines are parallel, they're never going to meet. There's no common point, right? So in this case, we say that the system has no solution. No solution. And the condition is, if we have a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, the condition is a1 by a2 has to be equal to b1 by b2 is equal to c1 by c2, not equal to, sorry, not equal to c1 by c2. Of course, you may not have seen this relationship, but you should remember this. Okay, this is a shortcut. As in, if you can use this directly in a question, you can get the solution in a within few seconds. Okay, within few seconds you can get the solution. But the basic intuition that is very clear, right? If you break the proportionality for the constant, the lines are going to become parallel. And we say that system is inconsistent. Inconsistent. Inconsistent means no solution. Inconsistent means no solution. Consistent means it has solution. So previous case, the case number 1 was consistent with infinitely many solutions. Here it is inconsistent. Here it is inconsistent. Here it is inconsistent. Clear? Is that clear? Is that clear? 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 Is that clear? Is that clear? Is that clear? Yep. Okay, now I also tell you one more thing. When you have two lines, when you have a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. What is the slope of the first line? What is the slope of the first line? I've already told you this. If I have a straight line in the general form, this is what we call the general form of straight line. The slope of a line is given by minus a1. So m1 is minus a1 over b1. Minus a1 over b1. Slope of the first line is minus a1 over b1. Yeah. And slope of the second line is minus a2 over b2. Okay. Now, this is a very interesting part. Please listen carefully. When you say that coefficients are proportional for the xy, when I say that the xy coefficients are proportional, forget about the constants. Forget about the constants. If I say that xy coefficients are proportional, we are saying that their slopes are equal. Why? See, if I equate the slopes, minus a1 by b1 is equal to minus a2 by b2. Okay. Now, this implies that your a1 by b1 is equal to a2 by b2. Now, just rearrange this proportionality. You get a1 by a2 equal to b1 by b2. So when you say that the coefficients are proportional, it simply means that these two lines have the same slope. They are in the same direction. They are in the same direction. So there are two possibilities. There are two possibilities. They can be parallel or they can lie one above the other. They can be coincident. So in this case, there are two possibilities. They are parallel and they are coincident. And parallel means what? A1 by A2 equal to B1 by B2. It's not equal to C1 by C2. Coincident means what? A1 by A2 equal to B1 by B2 equal to C1 by C2. Clear? So the condition inside the box simply suggests that they have the same slope. So that is true, right? When you have two lines with the same slope, it simply means that they are in the same direction. Slope is an indication of the direction of the line. Okay. So see, for example, you take these two lines. These two lines will have the same slope. Okay. Because slope is an indication of the direction. Or you can say that the angle it makes with the positive direction of x-axis. These two are parallel lines. They are making same angle with the positive direction of x-axis. See this? These two are parallel lines, right? So this angle and this angle will be same. If I consider x-axis, if I consider positive x-axis, this angle and this angle will be same. This angle and this angle will be same. You have seen this from basic geometry, right? These two angles are same, right? Because it's like two parallel lines being intersected by a transversal. Two parallel lines being cut by a transversal. Okay, the corresponding angles will be equal, right? Am I right? Tell me. Yeah. So I've already told you that slope is an indication of the direction, or you can say that slope is an indication of the angle the line makes with the positive direction of x-axis. So if I say this, they have same slope, it simply means that they are either parallel or coincident. Okay, so please understand this, the logic behind this. When I say that the coefficients are proportional, you're actually saying that the slopes are equal. Because for the first line, the slope is minus a1 by b1. For the second line, the slope is minus a2 by b2. When I equate them, you get the same condition. Is that clear? Clear? Please let me know. Is that clear? Please let me know. Hello. Is there any difficulty? Let me know. So in both these cases, first case was coincident lines. This condition was true. Here also this condition was true. The actual meaning was they have the same slope. Okay. And what distincts these two cases? How can you distinguish between these two cases? In this case, the constant will also satisfy that proportion. Here, the constants will not satisfy that proportion. That is a simple idea. Clear? Okay. Now the third case is intersecting lines. Intersecting lines. So how can two lines intersect? If they're not parallel or coincident, they will be intersecting. Or you can say that if they do not have the same slope, if they do not have the same slope, they are bound to intersect at some point, right? Like if you have two lines, if the slopes are not the same, they are different, they are bound to intersect at some points. Okay. Only if the slopes are same, they will go parallel. They will never intersect, or they will become coincident. Okay. Otherwise, they will go and intersect. That's the idea. So what is the condition for intersecting lines? There is no proportionality between the coefficients. That is, A1 by A2 will not be equal to B1 by B2. A1 by A2 will not be equal to B1 by B2. That is the condition for intersecting lines. So in this case, we say there is a unique solution. And also we say that the system is consistent. Even in the case of infinitely many solution, we said it was consistent. Here also we say it's consistent, but with unique solution. Consistent with unique solution. Consistent with unique solution. Consistent with unique solution. Consistent with unique solution. Clear? Is that clear? Is that clear? Is that clear? Let me know. Yeah. Now I'll just give an example graphically. If I see the inequality for the constant is broken here. Now, if I break the equality for the proportionality, not inequality, proportionality. The proportionality for constant is gone. That is why these lines are parallel. But the proportionality for the coefficients are still intact. See, we can see that 2 over 4 is same as 3 over 6. Right? In this equation, 2 over 4 is same as 3 over 6. 2 over 4 is same as 3 over 6. Now, if I break that proportionality as well, let's see what happens. So instead of 6, say if I write some 2 and the proportionality is broken, what happens? They no longer are parallel. They have different slopes. These lines make different angles with the x-axis, which means they are bound to intersect at some points. Interesting, right? Hope it makes sense for everyone. You have an intuitive understanding of what is really happening. Tell me. Please tell me, please tell me, please tell me, please tell me. You understand what is happening, right? When the proportionality is broken, when the proportionality is no longer intact, they will have different directions. So two lines in different directions are bound to intersect at some point, right? Yeah, very good. They intersect at one point. And in this case, we say that there's a unique solution. Unique solution. Clear? So that is the interpretation. We have 3 different cases. We have just seen all the 3 cases. Yes. Okay. Now when there's a solution, when there's a unique solution, how can we find that solution? So that is the next idea. We have seen all the different cases. We have interpreted it graphically as well. Now, our next question is, if we have a solution, how do you find that solution? So there are multiple ways to find the solution. Okay. I think you would have already come across these ideas. But anyway, we will discuss the ideas. So the first method is, of course, we are talking about cases when there is a unique solution. If there is a unique solution, how do we find that out? So first method is, of course, graphing. Of course, graphing. Okay. If you have a graph paper, you can easily plot them on the graph sheets and find the point of intersection. Or if you have a graphing calculator, plot them on the graphing calculator and get the solution. If you're graphing a straight line on on a paper using a pen or a pencil. Okay, say for example, let's see one question. How you can obtain a solution using graphing. I'll give you a simple question. Two x plus 3y is equal to x 8. X minus y plus 1 is equal to 0. X minus y plus 1 is equal to 0. Now, by graphing, how do you get the solution? If you're plotting on a graph paper with pen or pencil, you have to draw this graph, and get the solution. But if you have a graphing calculator or a graphing software like Algebra or Desmos, you can just plot them in the software or in the calculator. Do you have a graphing calculator? Do you have a graphing calculator with you? Or do you have a graphing software? If yes, can you just plot this on a graph and tell me what is the solution? Plot this on a graph and can you tell me what the solution is? By graphing. Okay, we're not talking about any other method right now. We're talking about graphing. We're talking about graphing. What do you think will be the solution? What do you think will be the solution? Can you just try to plot this using a graphing calculator? Or you can use a graphing software like Desmos or even GeoGebra. Can you try it and tell me the solution? Who can tell me the solution? Yeah, I want the solution. Solution as in the exact values of x and y. The exact values of x and y. The exact values of x and y. Yeah. That's right. Yeah, that's right. Others, can you just plot? I'm not looking at algebraic solutions, okay? I don't want you to do any algebraic manipulations. I don't want you to do elimination, substitution, or any other method. I want you to just plot the graphs. I just want you to plot the graph and get the solution. For that, you can use a graphing paper, graphing calculator, graphing software. Anything is possible. Whatever you have with you. You just have to plug in the values, plug in the equation to the calculator. Let's see. So let's plug in the values here. We have 2x plus 3y equals 8. We have x minus y plus 1 is equal to 0. Yep. Now look at the solution. What do you think is the solution? What is the solution point? What is the point A? The point where these two intersect. The point is 1 comma 2, right? It's 1 comma 2. It's 1 comma 2. It's 1 comma 2. That point is 1 comma 2. Am I right? One comma two is the solution. Right? Like sometimes, yeah, you have to use a graphing calculator to come up with the solution. Sometimes you need a graphing calculator to come up with the solution. Okay. But if you can plot on a graph paper, that is also fine. But during an SAT, the ideal method is to take up a calculator. If some graphing is required, but there are algebraic methods as well. There are algebraic methods as well. Okay, I'll give you one more question. We have y is 4x is equal to y, x plus 3y is equal to 3. X plus 3y is equal to 3. Can you just try it using a graphing software or graphing calculator and tell me the answer? Four x is equal to y and x plus 3y is equal to 3. Just a minute, I'll be right back. Please try to find the solution. Yes. Do we have the solution? Do we have the solution? Do we have the solution? Yeah. Okay. I'll show you. I'll show you. I'll show you. So we have 4x is equal to y. X plus 3y is equal to 3. Now, if I take the point of intersection, see, yeah, you're not getting good numbers, right? You're not getting good numbers. Yeah. So, like most of the time, graphical approaches are not is not an optimal way of solving it. Okay, so you have to understand that graphical approach is not an optimal way of solving it, because when you have complicated equations, it will be difficult. So we have to come up with algebraic approaches. Okay. Okay. Anyway, the algebraic approaches I will discuss in the next class. I'm going to wind up for the day. We have lost a few minutes, but I'll make it up sometime later. Okay. For the time being, I'm winding up for the time being. Okay. I'll make it up in the next class. All right. I'll share some problems with you. Okay. See you.